All right, this lesson is going to go through how to simplify a radical. So this is going to be more of the basic process instead of doing the multiplication, division, addition, subtraction with radicals. We're just focusing on the basics of how do I simplify a radical. So for example, if I wanted to simplify the square root of 9, we first off need to understand what is the square root of 9. Well, the square root is the opposite process of squaring something. So the square root of 9, when I look at that, we know that that's equal to 3, but why is it equal to 3? Well, the reason it's actually equal to the number 3 is because the number 9 is 3 squared. And a radical and a square are opposite operations, and they cancel each other out. So the radical and the square cancel each other out, and that's how we come up with the number 3 as our answer. The same thing basically happens when you have the square root of 100, for instance. 100 is actually the square root of 10 squared. And a radical and a square cancel each other out, and we find out that the answer is equal to 10. Well, now we can continue this on with larger numbers. So if I now try doing 280, for instance. Well, 280, it's not as easy to see what squared equals whatever. So what we're going to do is we're going to take the number 280 and we're going to simplify it down. We're going to factor it. If I take the number 280 and I factor it all the way down into its simplest form. Now there's definitely other ways of doing this, but this is just one of the ways that I usually show how to simplify a radical. So 280, when I factor that down, I get 2 times 140, and then 140 factors down into 2 times 70, and 70 factors down into 2 times 35. So instead of the number 280, I would actually write this out as the number 2 squared times 2 times 35. Now the reason I wrote it like that is because once it's written out as multiplication, you can break it apart. So breaking this apart, I have the square root of 2 squared, I have the square root of 2, and I have the square root of 35. A radical and a square cancel each other out. Now these, they cannot be simplified. They're already in simplest form. 35, technically, yes, we can break it apart. We can write it as 7 times 5. But even if I did that, we would have 2 times 5 times 7, which still does not simplify. But instead of leaving your answer as 2 times the square root of 2 times the square root of 35, or times the square root of 5 times the square root of 7, instead of leaving your answer like that, you actually take your radicals and you put them back together. This is root 2 times root 35. Instead of writing it as root 2 times root 35, we put them back together and we would write our final answer as 2 square root of 70. And that's your final answer now. So now we should be able to take pretty much any number and we should be able to simplify it with that basic concept. We should be able to simplify it by hand. So let's do one more before we get into the variables. Let's say I wanted to simplify the square root of, let's try 300. The square root of 300. Well, 300 is the same thing as saying 3 times 100. And some people have learned to stop at that point because of the perfect square. But like I said, I typically teach simplifying radicals by going through and finding that prime factorization. So 3 times 100, and then 100 factors down even further into 5 times 20, and then 20 factors down into 5 times 4, and 4, if you want, go ahead and factor it into 2 times 2. So the square root of 300 is the same thing as saying the square root of 5 squared, 2 squared, and then times 3. We can't forget about that 3. So that's how I broke apart the number 300. I broke it apart into 5 squared times 2 squared times 3. Now, when I continue to break this apart, I have the square root of 5 squared times the square root of 2 squared times the square root of 3. Well, a radical and a square cancel out. A radical and a square cancel out. And then there's nothing that we can do with this root 3, so we leave it as the square root of 3. So our final answer here, we would take 5 times 2 and get 10 root 3 as our final answer. So now how do we do this process with variables? I'm going to throw a few variables in there. And we're going to simplify. Let's go 580 x squared y to the third. We are going to simplify that. 580. If I take 580 and I factor it all the way down, I know that it's an even number. I can do a 10 if I want to. Let's do 10 times 58. And then 10 factors further into 5 times 2. And 58 would factor into 2 times 29. All right. The x squared, I'm going to leave that as an x squared. And I'll explain why here in a second. So I would have 2 squared times 5 times 29. And then I'm going to leave that as an x squared. But the y to the third, I'm going to break that apart. And if you want to break it apart into y times y times y, and then group 2 of them so that you see it breaks apart into y squared times y, that's all right as well. So any of these variables, you can break them apart. Even if I had something like, let's say I had z to the fifth, z to the fifth would be 1, 2, 3, 4, 5. So you can put 2 of them together, and you get z squared times z squared times z. So your variables, you can break them apart very similar as to how I factored these values down. So now when I have this broken apart, I would say that I have the square root of 2 squared, and then there's nothing we can simplify here. So I'm actually going to put those back together. So 5 times 29 would be, let's see, 45, 10, 14, 145. And then we have the square root of x squared, the square root of y squared, and then the square root of y. Now, when I continue to simplify this radical, radicals and squares are opposites of each other. They cancel out. So a radical and a square cancel out, leaving us with the number 2. A radical and a square cancel each other out, leaving us with an x. A radical and a square cancel each other out, leaving us with a y. But don't leave these two separate. They can't be simplified any further, so let's put them back together. When I put them back together, we would have the square root of 145y. And then this here would be your final answer, 2xy root 145y. That's your final answer. All right, so that's a brief introduction of how to simplify radicals, how to simplify numbered radicals, and also how to simplify variable radicals. So now we'll put those concepts together and we'll continue practicing those.